Eight Rivers is only inventing technologies to the extent that our product does not have a carbon footprint. Our mantra is that we will produce clean electricity at a price the entire world can afford, not just a bunch of rich people.
This is EnergyCast, and I'm Jay Dowenhauer. Today we're talking about a carbon capture technology that is less than a decade old, but could quickly become the standard for removing CO2 from fossil fuel power plants. It's so new that it wasn't on my radar until long after I left my role as executive director of a Clean Coal Foundation in 2010. More on my relationship with our guests in a moment, but first, let's discuss what's out there. I know a lot about this stuff. I used to speak at conferences around the country on carbon capture issues, and occasionally around my friends over a couple of beers while I was living in Austin. They were all really sweet to put up with me back then. So, what's carbon capture and why should we care? Simply put, it's the family of technologies that aim to remove carbon dioxide from emissions on fossil fuel burning power plants. You take out the carbon, these plants are essentially clean from an emission standpoint as nuclear or renewable energy, and it would make far more of a difference for carbon emissions. Fossil fuels produce 63% of our power. Renewables excluding hydropower, 10%. But carbon capture is challenging. You'd think power plant exhaust was pure CO2. It's closer to 15% at most, and that makes pulling it out selectively challenging and expensive. When you bolt on carbon capture equipment to a traditional power plant, we call that post-combustion carbon capture. NRG, our guest from episode 31, is doing that. It's proven and it works. But in the past 10 years, there have been other suggestions for isolating CO2 before it comes out of the flue gas. There was no reason to focus on these technologies before because no one really cared about CO2 until the last decade. CO2 isn't a pollutant like sulfur dioxide or nitrogen oxides. So that's led us to solutions like my guest from episode 23 at Ohio State, who's using chemical looping to isolate CO2 from the flue gas in the form of iron pellets. The chemical looping and process today's guest has developed fall into a family of technologies called oxy-combustion. It goes like this. The reason why CO2 is only a fraction of the exhaust gas is because fossil fuels are burned in air, which is mostly nitrogen. So if you burn fossil fuels in only oxygen, you'd get almost pure CO2, way easier to capture. The problem is that if you burned millions of tons of natural gas or coal with pure oxygen, you'd make the air separation companies very rich. The power companies, not so much. Our guest says that the eureka moment came when they suggested using CO2 instead of nitrogen in the combustion process. That way, you still use a little bit of oxygen, but not enough to make it unprofitable. The oxygen is combusted with the fuel, natural gas. It creates CO2, which then cycles around and around with more oxygen and fuel. It's called the alum cycle, and while the term was first coined in 2012, it has since captured the energy community's imaginations. The cost savings are incredible with this process. Because CO2 capture is baked into the technology, there's no need for extra capture equipment on the back end. The whole power plant is designed to create pure CO2 as exhaust, and I would argue that the decision to focus on capture from natural gas rather than coal was an unintentional game changer. More on that in a second, but I want to discuss where I came into this because this company plays a huge role in the direction my career has taken. It was 2016, and I had just moved to Charlotte but was still doing oil field work in Ohio. Through networking, I was invited to sit at a table at a lunch during a conference with EPRI, the Electric Power Research Institute. Sitting next to me was today's guest, Bill Brown, CEO of Net Power. He told me about his plans for a carbon capture power plant project he was working on down in Houston. My immediate response was, they're still doing carbon capture? I'd left that life years ago, but they were definitely doing carbon capture, and 2 years later, they had a working 50-megawatt facility down in LaPorte, Texas, near Houston. Net Power is a subsidiary of 8 Rivers Capital, a company based in Durham, North Carolina that Bill founded with longtime associate Miles Palmer following the 2008 financial crisis. Bill had been a managing director at Morgan Stanley before deciding he wanted to build something good for a change, as he put it. The Net Power project, as we know it in Houston, originally started as a coal-fired technology, but Rodney Allam, who's now a principal at 8 Rivers and the lead behind the plant's technology, pivoted to natural gas. I'd argue that this was critical because, in this country at least, no one cares about new natural gas plants. However, they will grind a utility to a halt over a single coal-fired unit. So not only is Net Power capturing carbon, they're doing it with a fuel source that has little public opposition. My guess is this technology will proliferate in the United States much faster than had it been coal-based just on its public perception merits alone. I hope you enjoyed my conversation with Bill Brown. We are with Bill Brown, CEO and co-founder of 8 Rivers Capital and the CEO of Net Power. And Bill, you guys are a capital firm by trade, not a GE or a Westinghouse. So why do you think it was this blend of talent that got this project done and so many others have failed in the past?
We actually found inspiration in Silicon Valley.
Yep.
And as much as they screwed up in '08, the clean tech innovation world, we realized that there is actually a way to apply the lean innovation model to capital-intensive industries. Most people, when you hear me say that, you'll think that this guy just said something that doesn't make sense to me. How can you do lean in capital-intensive industries? Because lean is about taking an idea, iterating it repeatedly to a customer base, and improving it and making it better real-time rather than having it fully born, fully formed on the scene at launch.
Works great for software.
Right.
Not so much for big power plants.
Exactly. So what we did for this, we actually break the lean model into 2 pieces. The first part of the iteration happens with our capital raising. We started that on coal. We go to Babcock and Wilcox. Hey, what about this great idea on coal? And Babcock and Wilcox looks at it and say, we're going to do a lean thing here. We're going to spend 3 months on this, looking at this. We're going to tell you, number 1, it works. 2, don't start on coal. 3, you should do this, that, or the other thing. That was the beginning of the lean process. Now, how do you get basically $2 to $3 million worth of free consulting advice for every firm you go to? You've got to be big enough that they want to invest the time and effort to do the due diligence. So that leads to another filter. Everything we do has to be $1 billion revenue in 5 to 10 years, at least line of sight on that. And you'll get the attention of large companies. Another problem, though, is how do you get someone to fund that in a capital-intensive industry? Well, we have to go in at the level of someone who cannot be fired. Because if somebody spends $100 million in an organization and it doesn't work, that person will probably be fired. Well, there's one person in the organization who will not be fired, and that's the CEO. Our entire process of raising money and qualifying all of our projects is we come up with the idea, we iterate with large companies, we go in at the senior levels of the organization because we do have $1 billion idea, and therefore the senior levels of an organization want to hear about it, and then the funding event happens. Now we look lean again. A normal lean operation takes a shoebox, throws some cash in it, and a team in it that's already worked. They tape it up, they punch some holes in the bottom of that box, and they iterate lean out to their customer base. We take that shoebox and we flip it upside down. And instead of having a successful team of a previous startup, the people who go in that are the people from places like Exelon. When you're finished, they go back.
Yeah, because I was about to ask, you partnered with Exelon, a utility, yep, CB&I, and Toshiba, and I think all 3 of those have built power plants on their own. I think they probably all built nuclear power plants, if I'm not mistaken.
That's right.
So you managed all of this out of Net Power? You didn't hand the reins over to any of them?
No, we didn't. Well, we handed some reins over. What we do is, in that model, the people at 8 Rivers end up being the people who innovate. The Exelon people rotate experts in and out of the company. We have a test facility in LaPorte. That's all staffed by Exelon people.
Yeah.
They know how to run power plants. I don't. None of the people around here do. When we had to get permitting done in Texas, they knew how to get permitting. When McDermott was doing the engineering, the steel into the ground piece, they know how to do that. I don't know how to do it. The goal here is that we have a lot of different team members operating simultaneously and adding their talents to it. Now, why didn't one of those try to take over? Because that's a really good question. If we only had one investor, I think they would have. But by having multiple investors simultaneously, they keep each other in check. And so you become more of this joint venture between at least two large behemoths rather than this organization that they almost consider to be a de facto subsidiary.
A new co,
Yeah.
right? Take us back to the beginning. What I'm really interested in is Rodney Alum. He's the inventor of this process. My understanding is the first time this was ever publicly published was 2012, right? I mean, they got polo shirts older than that, you know?
Yeah.
But I love the fact that this concept, this alum cycle process is just being used in all these stories, like we're talking about Newton's third law of physics. It's such a new concept, but it seems like it's just kind of been understood as something like the Rankine cycle.
Yeah.
It was written that he was first working on this around 2005. He kind of took a leave of absence to work on this so that it would be his IP. And then it looks like you guys contacted him right around 07, 09. So how did you guys come together, especially when he was not on anybody's radar?
Well, Rodney left Air Products in 2005. Rodney wasn't working on this until, we came along in 2009. Rodney had been working on turning natural gas to liquid fuels. I had called up an old friend of mine from MIT and said, listen, I'm looking for someone to work on a power plant design. We had, at 8 Rivers, designed a clean power plant that was based on oxy-combustion.
But this was still with coal, right?
Still with coal, and it used a steam cycle.
And you were not gasifying first. It was post-combustion carbon capture,
That's right.
oxy-combustion.
That's right. And so when I looked at the economics of that were awful. And so I said, we're killing this. We cannot do oxy-combustion on coal. It's a stupid idea.
Right.
I mean, that was one of the things about Wall Street that's really helpful. Wall Street teaches you how to cut your losses.
Kill your darlings.
That's right. And finally, I interviewed a bunch of people and finally came back to Rodney, flew over to London, and then in that room, he said, well, I wonder if we could use CO2 instead of steam.
So he hadn't been working on this.
No.
He just came up with, it's almost like a napkin moment.
Yeah, it is. Rodney started going faster than I could at the time because I didn't understand what I now understand a lot of.
Using the supercritical
That's
CO2 and all. Yeah, I don't think anyone had. Yeah.
And so I called up my business partner back in the States and I said, this is the guy who will make this happen.
Yeah.
And we flew him over and Rodney joined 8 Rivers Capital as a principal.
Right.
Rodney is a guy who cannot use spreadsheets. He uses a 4-function calculator, a 0.5 millimeter pencil. So we found there's one guy here in the Triangle area. His name is Jeremy Fetvet. Jeremy was really good at taking a bunch of these ideas and putting control systems around them and thinking through the process. And by virtue of the work that Rodney and Jeremy did, we got the beginnings of the cycle. And then at 8 Rivers, we kept hiring teams of people.
Now, Bill, we go back. We first met an EPRI table at a Charlotte Business Journal event about 3 years ago, and you successfully fired up 2 years later. And when we were talking, of course, I think the plan was to maybe start operations in late 2016, early 2017. It happened in May of 2018. Not really much of a delay for something that's really a first of its kind, but a little bit of a delay. So now that it's been fired up for almost a year, what did you learn? What do you think you could have done differently? What were some of the lessons learned here?
Let me tell you the reason for the delay. Originally, Toshiba was going to ship the turbine and combustor to us in 2016. Then they came to us about a year before the thing was going to ship, and they said, well, we've actually decided that we want to test the combustor separately. And we said, we thought that you should always test the combustor separately. And then they told us that they wanted to test the combustor in what's called a blowdown rig. Basically, you get a big tank of CO2, a big tank of natural gas, a big tank of oxygen, turn up all the spigots, light the match, and about 15 seconds later, it's all finished.
And they wanted to do all this in Japan?
Actually in Germany. They were going to do it in Germany. At a rocket test facility in Germany. And so we ended up convincing them that the thing that we were building LaPorte is the ideal test stand for a combustor. And we also knew that the combustor is the most important part of this because everything else is just...
The site is where an air separator is already located,
Yeah, it's right next to an Air Liquide site.
So that's already, that's old tech
Yeah,
too.
air separation's old tech. All this stuff is old tech. But the combustor, where you pull in 94% carbon dioxide, I mean, think of it. A gas turbine is the same as a jet engine on the side of an airplane. We wanted to do that jet engine except for one thing. We wanted to replace that nitrogen with 3 times as much CO2 CO2. So we never knew if you took this giant amount of CO2 with small dilute oxygen piece and put it to the front of a jet engine, would that combust at high pressure? That's the one piece we didn't know. So we were all in favor of doing this combustor test separately on the site. Furthermore, we could operate the entire site, throttle it up and down without worrying about what's going through the turbine blades. So the entire thing was operating, except no hot gases were going through the turbine blades. The shaft was rotating on the turbine. Well, to make that separate combustor test, we had to stop construction and we had to build a whole new facility on site that was not originally planned.
So everything is being built in Houston.
In Houston.
And then you stop and do this combustor test. And
we had to build it. We had to design the whole rig. So all of a sudden, we injected a 1.5 year delay into our program.
Change order.
Change order. It was a massive change order, but the amount of data that we got out of that was absolutely incredible.
You feel like it was worth it?
Oh, definitely worth it, because the combustor that got tested now, rather than through a blowdown test, is the combustor times 10 that will be used on the full-scale plant.
Right. Well, the pilot is an experiment anyway.
Yeah.
The pilot's not practical.
That's right.
A pilot's supposed to be to learn, so you can scale up. And speaking of scaling up, is the plan still to move forward on 300 megawatts? Or?
Oh yeah, we've gotten enough data at this point that we have done a design freeze on the full-scale plant.
And are you concerned about any scale-up issues? Any ideas of maybe just doing them in series or anything?
So here's the reason we're not worried about scale-up. Combustor, same size, same combustor, no scale-up.
Really?
We had no scale-up of the combustor. We'll take that same combustor down in Houston and just use 10 of them.
Okay, so the magic box is really the combustor. I mean, that's where the magic happens.
That's right.
Okay, so you are going to just do a series.
We've got a full-scale. The full-scale combustor is already there.
Yeah. So you can just add on modular.
That's right.
That's beautiful.
To put it in terms that your listeners will understand, we tested our spark plug and our piston on a lawnmower, and we're now putting 8 of them together to make a V8.
That's right. There's just more of them. Another article said that you originally considered going after DOE grants. I think you covered a little bit of this in the beginning. This was back when they had was it the TARP? Not the TARP, it was the one after that. It was the Reinvestment Act, right?
Yeah.
So there was a lot of DOE money going around. It said that you guys considered it, but then I guess it was insinuated you did not. You went another way. But weren't all those grants written coal specific?
They were.
And so now that you guys have successfully put something in the ground, you didn't have to do a DOE grant. Any advice for the people who do those prizes for would-be innovators? Any thoughts on that?
Yeah, sure. First of all, the Recovery Act was actually the thing that started this.
Yeah.
The fact that someone decided to write that legislation and put all that money for coal in there made us think that we should focus on coal. Number two, most of that money that was allocated was never ever spent. I think it was a good idea, and I think it was a bad idea to let it expire. What I would do, I would simply say, if we invest the money in a facility, we will get 10% of the cash flows out of that facility. And therefore, those cash flows, to the extent that some are successful, will replenish the funds to invest in other things.
So it really would be an investment act in that work. I always thought that maybe one of the things could have been technology neutral, more like outcome neutral,
right?
You know? And look, I mean, when you first told me back those years ago, we're doing something where we're going to do carbon capture for natural gas, I was like, no, natural gas, why not coal? But flash forward to 2019, you're going to do carbon capture for natural gas. No one cares about building natural gas plants. In fact, they encourage them. In the world of renewables, you need them. There's just a whole lot more, I think, acceptance to natural gas in the public than there is to coal. So I think that's another win for you guys.
Well, for the United States, that's true. And first of all, we are going to solve the coal problem for the rest of the world that does use coal.
That's right.
And unfortunately, we think that the rest of the world looks like America, and it doesn't. Our mantra is that we will produce clean electricity at a price the entire world can afford, not just a bunch of rich people.
That's right. Look, because I've always said this, developing world, electricity is a right. You know, and it is a crime to deny the developing world baseload energy just because we burned a lot of carbon a long time ago. How important are tax incentives for carbon sequestration and EOR? Because you talked about it being affordable. It seems like you found a way to be affordable without these kinds of incentives, subsidies, if you want to call them.
I can't deny that they help us, and I do think that they help make the playing field a bit level. If I were running Congress, I would get rid of a lot of these tax incentives in general to levelize levelize the playing field. And then I would actually go back to the Recovery Act and provide grants for first-of-a-kind products, because the goal is the big valley of death is getting to first-of-a-kind. And if you can get to first-of-a-kind, the private sector will fund it.
Everyone's always scared to jump in at the very beginning. When I was executive director of the Clean Coal Technology Foundation of Texas, we always talked about enhanced oil recovery and carbon sequestration, essentially just burying it. Carbon sequestration, is there ever any real reason that we would ever, as an economic answer, do carbon sequestration?
Actually, well, first of all, at
It's
this
expensive
point,
and you don't make money from it.
Actually, let me address that. I'm glad you brought it up. Every other technology costs around $30 to $40 a ton to capture CO2. Our marginal cost is around $1 to $1.50 a ton. That's it. If we wanted to put it into the ground for carbon sequestration, we could put it in the ground for around $5 to $7 a ton. That means if there were ever a carbon tax, or if we simply wanted to pay to be green, the marginal cost of one of my plants of putting it in the ground is $5 million a year. A net power plant takes in $40 million worth of natural gas a year, throws out $90 million worth of electricity a year, throws out $12 to $15 million worth of CO2 a year, priced at $15 a ton, which is dirt cheap price. 45Q will add another $36 million on top of it, and then the argon's another $21 million on top of it. If I simply wanted to put it in the ground, it would cost me $5 million.
And the government will pay you to put it in the ground, thanks to, you talked about 45Q.
But think about it. Think about it.
But even without that, you're saying that you could still can make sense.
If I wanted to be a good corporate citizen, say there's a corporate citizen I want to pay to have my CO2 sequestered, it actually makes sense. And this actually gets something that goes to the very core of the Eight Rivers business model, and that is Eight Rivers is only inventing technologies to the extent that our product does not have a carbon footprint. If someone wanted to build a net power plant and they did not want to sequester the CO2, we wouldn't let them.
Well, that's good. Good on you. And by the way, when I went to business school back in 2006, one of the things I said was I want to be an envirocapitalist. The most cost-effective solution can also be an environmental one. And it seems to be like here you are right here, proving that. You've also been quoted as saying, we've invented something that might save the planet. That's real, true believer right there. Do you think those pushing, and I hate saying this on this program, but it gets a lot of oxygen these days. Do you think those pushing for a Green New Deal would agree with that?
When IBM introduced the PC in 1982, it had no idea what would happen. When McKinsey was asked by AT&T about the market impact of the cell phone, they didn't have any idea. In 1998, when the IEA wrote one of its reports with the Nuclear Energy Agency, there's this one paragraph in there that says, photovoltaics, wind, and fuel cells will never be part of a utility system because of their intermittency. Now think of that. People who thought that they knew what they were talking about and did know what they were talking about, they were wrong. Anyone doing a Green New Deal or any New Deal, here's the challenge. Do not think that because you think you see today clearly that you have any idea of what tomorrow will bring.
Right.
And if you create a piece of legislation that denies the potential for technology, you basically put the nail in so many coffins, all because of your hubris.
Right. Picking winners.
Yeah.
Anything else new coming on?
So Eight Rivers has worked on developing a way of taking sour gas, which is otherwise worthless gas, and processing it for really cheap. We can produce sour gas so cheaply, we can use it as a feedstock for producing hydrogen so that it will be so cheap that it will not only be used in automobiles, but you can burn it in existing gas turbines and existing coal plants without an economic hit.
So you really do believe in a hydrogen economy?
I do.
It bounces around a lot, and I hear it every now and then. But
Well,
you really
tell
think-
you, if I produce hydrogen at 35 cents,
Yeah, people might buy that.
out of necessity.
I'm sorry, 35 cents a kilo.
Like 35 cents a kilo, which is $2.85 an MMBTU. If I produce hydrogen that is equivalent in cost to natural gas, you'd use it all day long.
It's pretty exciting. I'm going to finish with a lightning round of your thoughts on different energy technologies. Natural gas,
Not just to bridge a destination.
crude oil,
High processing costs, we can use it in some way that's clean.
Nuclear.
If the world really cared about climate targets, we would have a lot more nuclear.
Yeah, I agree with that. Amen. Coal.
People assume coal is dirty. There's some people out there who are going to make it clean.
Wind.
Wind is everywhere, and I'm always shocked by how many people support wind but don't want to see it.
NIMBYs. Solar.
The ultimate solar will be solar collected in space and beamed to Earth.
Oh, you should check out my episode where I interview the guy from Naval Research Laboratory. Biofuels.
Don't seem economic, and it seems strange to think that humans can do better than nature, but it actually might be true.
Hydroelectric.
Hydroelectric was the original renewable. Hydroelectric has the same problems for some people as wind. They just don't want to see it in the wrong place.
Geothermal.
I think geothermal is the dark horse. We're working on something that will be able to insert electronic semiconductors into the ground and using just those semiconductors pull power out of the ground in the same way that PVs pull power from the sunlight.
That's pretty awesome. And look, base load renewables. I just don't think we hear enough about it. Energy storage.
Number one, there has been an assumption that Moore's Law applies to batteries. That is not true. Moore's Law has a basis in science and fact, and it applies to semiconductors. And those people who try to extend it to batteries simply don't know what they're talking about.
You don't think it's going to improve that fast?
It won't improve that fast with lithium. Now, it could improve with other things. But the most important thing about storage is this. There's a huge difference between electrons and protons. If I had this cup of coffee in front of me full of gasoline and I had an equal weight lithium-ion battery, the gasoline would have 38 times more energy than that lithium-ion battery. So do not underestimate protons, and I do believe that for storage of the future is all going to be protons, whether it's pumped water, pumped air, creating ammonia, whether it's creating hydrogen, burning it back. The future of storage is in protons, not electrons. The people who are chasing batteries, given today's technologies, are not chasing something as substantial as I see protons today. It can change in the future.
Great point that we're not just talking about batteries when we're talking about energy storage. Electric vehicles.
About 3 or 4 years ago, I asked a group of people how many people in the room thought that battery electric vehicles would be over 50% of the vehicles on the road by 2050. And everyone raised their hand and they flipped it. And they said, well, who thought otherwise? And my hand went up. And they said, Bill, what do you think? And I said, it'll be hydrogen. That was 4 years ago. No one in that room thought that hydrogen was going to be anywhere close. And everyone in that room that I now see again said, Bill, hydrogen is the dark horse, and I'm surprised we didn't all see it.
Energy efficiency.
Energy efficiency is the low-hanging fruit. I mean, just look at the difference between an incandescent light bulb and an LED. People complain about different shapes of outlets all around the world as they travel. I say the outlet that goes all around the world is a USB plug.
Think about how energy efficient your process is.
Yeah.
For years, it was always parasitic load. Never be able to capture carbon without all this parasitic load on the plant. And then finally, last one, nuclear fusion.
It's going to happen. We're 30 years away, and we've been saying that for 50 years.
All right, Bill Brown, I cannot thank you enough for this time, and also on behalf of the whole industry, everyone who's been working to try to do carbon capture. It looks like you've nailed it, and best of luck to you in the future. Thank you so much for your time.
Thank you so much, because I tell you, when you look at the history of Silicon Valley, the most important thing in my belief in the history of Silicon Valley was the San Francisco Chronicle, and it required people like you getting out there telling other people the stories of the successes. Thank you very much.
You bet. That was Bill Brown, co-founder and CEO of 8 Rivers Capital and CEO of Net Power, a carbon capture power plant developer based in Durham, North Carolina. For a modest office like 8 Rivers, you wouldn't believe some of the projects they are working on. In addition to revolutionizing power plants, they are working on a space launch technology to rival Elon Musk, gigabit fiber communications, in addition to the other energy technologies he described in the interview. I want to thank Bill for his time and for a small conversation 3 years ago that has led me to my current position, the EnergyCast podcast, and a number of side projects that I thought I'd never return to. Back then, I thought our energy future was just wind and solar farms. And as you've taken this journey with me, we know that there is so much more. And I also want to thank Adam Goff at 8 Rivers for setting up the interview and then waiting patiently when Bill and I went way over our time. I apologize and hope I'm not banned from the office forever. You can find plenty of pictures on online at energy-cast.com and on Instagram at Host Energy. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 55. Be sure to join us next week when we return to the Naval Research Laboratory for my fourth and final interview. You know how frustrating it is to never be able to recharge conventional alkaline batteries? Our guest has found a way, and it could revolutionize battery technology as we know it. You won't want to miss it. Until then, I'm Jay Dowenhauer. We'll see you next time.